Good morning, good afternoon, good evening, everyone, and welcome to today's webinar on faster analytics through data warehouse augmentation. My name is Vijay, and I'll be your host for today and also one of the presenters for the session today. But before we begin, I just wanted to start with a few logistical reminders. One, this webinar is being recorded and you are currently in a listen-only mode. But you may submit questions anytime throughout the session using the Q&A chat function in the lower right-hand corner of your console. And we'll try and get to answer everyone's question after the presentation. Also, this webinar is being recorded and you will receive an email with the link with the recording to the session later today. In the meantime, if you wish to contact us, please email us at team@singlestore.com. Okay. Let's go on to the agenda today. But before I move on to the agenda, I just want to do a quick introduction. So as I mentioned, my name is Vijay Raja. I'm a director of product marketing here at SingleStore. And prior to that, I spent about 18 years in various roles in IT data and analytics, including last 6 years with Cloudera, where I was leading their industry and solution marketing functions. And also joining me today is Rick Negrin, who's our VP of Product Management at SingleStore. Rick oversees product strategy, product management at SingleStore, and works closely with many of our customers to help them accelerate their data journeys. Prior to SingleStore, he spent about 12 years at Microsoft leading teams for SQL Server as well as their Azure SQL databases. Welcome, Rick. Great to have you here.
Thanks, Vijay. Very excited to be here to talk about SingleStore.
Awesome, fantastic. All right, so what do we have today is we want to start with just talking a little bit about data warehouses. What is it good for? What is it not really ideal for? What are some of the key challenges that organizations encounter when they have the typical data warehouse architecture? Rick will talk a little bit more about some of the augmentation patterns on how customers augment their data warehouses with SingleStore and why. And then most importantly, the most fun part is really the customer case studies, right? So we have 4 different customer examples from different verticals talking about how they are accelerating analytics by augmenting their data warehouses with SingleStore. Last but not the least, we'll definitely have some time for Q&A towards the end. Okay, so we have lots to cover there. So let's jump in. So data warehouses, we all know what data warehouse is, but what are these really ideal for, right? So if you look at data warehouses, they're really an indispensable tool for any modern enterprise today. And it allows decision makers to analyze and enable business intelligence and analytics on large amounts of data. Data warehouse typically consolidates large amount of data from multiple sources, and you can obviously ingest, store, filter, extract, and analyze these large data sets to drive insights, right? And a lot of these data warehouses typically this data is then served to BI tools, to SQL clients, and other analytical applications, right? Now, the fact is that the data is usually structured and loaded into predefined schemas and tables, right? Which is kind of the data curation process. And data warehouse is really good at aggregating the data, delivering predefined report for a set of users, right? That's what data warehouses are really good at. Now, data warehouse is not ideal for in some scenarios, right? So for example, if you're dealing with fast moving data, streaming data, when you have to do streaming data ingestion from diverse sources, data warehouse is not really ideal in those situations. Data warehouse is not ideal for when you have to drive insights and analytics in real time, right? When you're trying to drive low latency query performance, sub-second latencies, or even really low latency query performances, data warehouses tend to struggle sometimes in those scenarios. And also data warehouse is not really ideal for supporting ad hoc analytics. So which means if you have to do interactive analytics, if you want to do interactive dashboards, do a lot of sorting, filtering, and interactive analytics on dashboards, powering those with data warehouses tend to be problematic. They were not designed to do things like that. They were not designed to do real-time analytics. They're not meant to power external applications, right? And another big challenge that we typically hear about is when you have to drive performance for highly concurrent workloads, right? So if you have high number of users or high number of queries hitting the dashboard or the application, powering those with data warehouse can be highly challenging. It's going to be really tough to scale to those level of high performance with high concurrency needs for your applications and dashboards. Okay. Now, in order to understand a little bit more, I think it's important to look at what does a traditional data warehouse architecture or kind of a landscape look like. Like, what does the end-to-end flow look like? So typically, you will have, on the far left, you have, all of the OLTP data sources, transactional data sources, your SQL servers, MySQL, Postgres, all of the operational databases that then they have to go through an ETL process, extract, transform, load process, to clean the data, cleanse the data, and make it in a structure and format that the data warehouse can then analyze, right? And then load that data into the data warehouse. So you either have to follow an ETL process, or in some cases, data warehouses has tools where you can do an ELT, where you extract and load and then transform that data in the data warehouse so that you can actually curate it, cleanse it, and then use it for analytics to drive intelligence to other downstream applications, right? So in the ETL segment, you have, of course, your big players, Informatica, Talent, or you could be using scripts to do those ETL operations and then loading the data into the data warehouse. And when I'm talking about data warehouses here, I'm not referring to not just the legacy or the previous age data warehouses such as the Teradata's, the Verticas, or the IBM NetEases. I'm also referring to the cloud data warehouses, including Snowflake, BigQuery, Redshift, so on and so forth, right? All of them typically follow this pattern or this end-to-end workflow when it comes to ingesting the data, cleaning the data, transforming the data, and then making it available to analytics and pushing the data to, dashboards, applications. You might have Tableau, Qlik, Pentaho, whatever you're using today for your analytics, right? But the fact is, this already has some inherent challenges or bottlenecks. This flow already has some inherent challenges or bottlenecks built into the process. So let's look at a few of those. So for number one, your data warehouses are not meant or not built to do streaming ingest. So if you have real-time data sources, if you have data sources that is sending out data every second, every millisecond, whatever it be, and you have to do analytics in real time, it's really tough to, your data warehouses were not built to accommodate streaming ingest, right? So that's really one bottleneck we see today with the legacy as well as some of the cloud data warehouses here. So that's number one, streaming ingest. Number two is ETL batch windows, right? In general, batch windows is really the process everyone loves to hate, right? I've never met a developer or an engineer who's happy with their batch ETL setup, okay? Because you have latency built into the system, right? Typically, what happens is that once you get the data, that ETL window could be anywhere. It could be 2 hours, could be 6 hours, could be 8 hours, 12 hours. We even have clients where some of their ETL windows were 24 hours, which means your data warehouse and your underlying, and your downstream applications and dashboards does not refresh with that data. Is not, you're facing data sanity issues when you look at that level of ETL batch windows, right? So that's kind of the second big challenge is around ETL batch windows. The third is really around query latencies. As I mentioned earlier, data warehouses were not built to do super low latency queries for real-time analytics, for sub-second latencies, or anything that requires kind of a real-time interaction, that type of things. Data warehouses were not custom built for that. So there are obviously some challenges around doing real-time analytics and query latencies for, especially when you have high concurrency workloads, right? Which kind of leads us to the fourth bottleneck, which is when you have high concurrency, when you have to scale to hundreds of thousands of users, or when you have thousands of queries that is running simultaneously. This is a classic case where data warehouses tend to buckle us. It's not easy to scale your data warehouses to meet the high concurrency requirements from your dashboards or from your applications. You can still do it, but it's not going to be probably cost effective to do that purely with a data warehouse, right? So those are some of the big, I would say, the bottlenecks or challenges that we see with the traditional data warehouse flow that's happening today. So what does that mean? What are some of the key outcomes of these challenges that we talked about? So we talked about streaming data ingest. We talked about sluggish query response times, especially with high concurrencies. We talked about cost effectiveness to scale when your concurrency loads increase, right? So what that means is typically the outcomes or symptoms are some of these. You end up with slow running dashboards. Like dashboards take forever to refresh, is not fast, and it's not really interactive. It's not giving the right experience that your customers or your employees need. You get that dreaded pinwheel when it comes to when you try to refresh your dashboards, right? Or your request keeps getting timed out. All of these are symptoms and outcomes of some of these challenges. That's one. The number, and secondly, it's stale analytics. So as I mentioned earlier, the dashboards really are your downstream applications of dashboards don't reflect the most up-to-date information for it to be valuable to users, right? So data is not refreshed timely, and that's primarily because of the kind of the ETL batch windows that you have to go through, making it really ineffective for teams to make decisions in a timely moment, right? So that's really a challenge. And last but not the least, we talked about it's expensive to scale, especially when you have high concurrency requirements from your dashboards and from your applications. So those are kind of the key challenges or outcomes that you kind of have to deal with from a legacy data warehouse standpoint. So I want to build that context to talk a little bit about single store now, and what single store does, and how we kind of effectively augment data warehouses to drive value to our customers. So what we offer today to our customers is really a unified database for fast analytics. What do I mean by that? What we offer is a distributed cloud-native relational database that's designed to run both operational as well as analytical workloads with great performance, right? So if you look at the left, you have the traditional transactional workloads, operational databases, and then on the far right, you have analytical workloads. This is where a data warehouse would typically fit in, right? What we bring together is the best of both worlds: super fast transactions and lookup of an operational database, together with the scalable analytics of a data warehouse. So you kind of get the robustness and performance of an operational database to power your analytical queries and analytical workloads. And the way we do this is by what we call universal storage. So we have an in-memory row store, which is ideal for fast lookups, fast writes, with super low latency response times. So ideal for super low latency type queries, right? So that's the in-memory row store. We combine that with a memory and disk-based column store, which is ideal for compressed data, fast reads, and analytics that can really scan billions of rows. So really, we bring these things together to drive fast analytics on fast data, if you will. So what are the three key attributes? I want to dig in a little bit further and talk about three key capabilities that single stores bring to the table that can effectively complement when we are using this in conjunction with the data warehouse, right? So three key things that we bring to the table. Number one is really around ultra fast ingest, right? So we're really talking about parallel high throughput fast ingestion. It could be up to billions of events per second from distributed data sources such as Kafka and Spark. Now, if you think about it, this is usually, as I mentioned, this is usually a big bottleneck for other data warehouses and even the cloud data warehouses and traditional data engines. And when we talk about fast ingest, for some of our customers, we are ingesting like 12 million transactions per second for a bank, right? With over 60,000 concurrent queries running every second. So that's really the ultra fast ingest. The second pillar is really talking about super low latencies. This is really around how we provide super fast query performance, right? So when we do queries, we deliver sub-second latencies, usually millisecond latencies response times. And for many customers, their SLA is 20 milliseconds or less. And for some of the customer-facing applications, it's 10 milliseconds or less, right? With concurrency of over thousands of users or thousands of queries. Which leads us to the last, the third pillar, which is all around high concurrency. This is really the number of users that need to access the applications number of users, or it could be the number of queries that needs to access the application simultaneously, right? So again, we have customers where we're doing 60,000 concurrent queries for one of the banking customers. Another one, 40,000 users for a wealth management dashboard, so on and so forth. So great example. So again, all of these become key pillars when you're trying to deliver fast, responsive dashboards, fast applications, or even really provide really interactive analytics to your users. Okay, and so what customers are doing is they are augmenting their existing data warehouse infrastructure, be it Redshift, Snowflake, Teradata, Vertica. We have examples all across the board, which we'll get to in a few minutes. But what they're able to do is they're able to move workloads from these data warehouses into single store, or streaming data directly from all of the different data sources, from your operational data sources, from your batch sources, or from the new streaming real-time data sources. You can stream data directly into single store through pipelines and use that to power, as I said, fast applications, fast dashboards, fast reports, so on and so forth. Okay. Now we have 3 specific patterns that our customers are using today to do the augmentation, and Rick is going to talk a little bit more about the specific patterns and the architecture in a little bit. So why are customers doing this? Well, I think the proof is in the pudding, right? These are, by the way, all 3 are real customer examples of ours, where, as I mentioned, they are trying to drastically improve the performance of their applications, or their analytical performance of their dashboards or the tools, to really make sure it's useful and to really enable their end users, right? So for example, the first one is a tier 1 media and entertainment company. It took them about 2 hours to ingest data, just to get the data into the data warehouse, and then another 5 minutes to do a query, right? What they were able to do is they were able to augment the data warehouse with single store and look at the results. 2 seconds, real-time data ingest into single store with 2 seconds to actually query. So dramatically bringing down the time to insights for customers by augmenting their data warehouses. That's one example. The second example, again, is a digital retailer. Again, as you can see, more than 24 hours, talk about batch windows, right? 24 hours to get the data into the data warehouse, and then do analytics. Their dashboards were just not getting a refresh in time to make it really usable for the end audience. So they ended up, again, augmenting the data warehouse to drive very, very impressive results and fast analytics for their audience that they're using the applications, so on and so forth. So what we'll do is we'll get into some of these examples in more detail later today. But I just want to give you an example. So where are we doing this? We have examples all across the board, across different industries, as you can see here. And we have worked in augmenting Snowflake at, you can see a couple of examples here. Tier 1 US bank, where they were trying to do real-time marketing and campaigns based on data that's coming in fast. We are also working with a cybersecurity firm who's trying to do real-time threat analytics and reporting. Again, augmenting Snowflake with single store to drive those type of use cases. Same with Teradata, as you can see, examples of use cases around IoT and smart metering. We have the real-time executive dashboards that goes all the way up to the CEO level that they're using to make decisions that really pivot and really change the market momentum for these companies, right? And again, we have examples across Snowflake, Teradata, again, Redshift, as you can see here, and also Google BigQuery. What we will do later today is also go deeper into 2 or 3 of these customer stories, so that you can get a deeper sense of how customers are doing this, what were the motivations behind doing this, what are the use cases, and then how do they really, and what are some of the business impacts from doing this data warehouse augmentation. So as you can see, this is a mature play this is a very consistent play that we are seeing across our customers, both big as well as small, to really drive some fast insights and fast analytics from all of their data. Okay. With that, what I want to do is I want to now transition to hand this over to Rick to talk a little bit about the data warehouse augmentation patterns and how customers are actually going about augmenting their data warehouses with single store. So Rick, over to you. And Rick, if you're speaking, you're probably in mute.
Sorry about that. Thanks, Vijay. So Vijay did a great job explaining kind of what the problems people have and why they moved and what the value they get. So I'm going to dive a little deeper into the patterns that people use in order to achieve this outcome. So what we have here is the typical pattern that you'll see. You have an operational database that's usually backing some application. Then you take the state out of that database periodically using some sort of ETL process and likely an ETL tool, often on a batch basis, so once a day or maybe once an hour at most. You maybe do some aggregations, transformations, and then you stick it into your data warehouse into some common schema that you can then pull out and use in your reporting and your dashboards. Now, as Vijay described, there's a couple of problems that people run into when they're using this pattern, right? That you're not getting the data in real time because you're pulling it in batch, so you're not streaming it in, and you have sometimes fairly large batch windows, right? And the query latencies you get out of a data warehouses are designed to handle large data sets and complex queries over those large data sets, but they were originally designed for reporting, where you're generating the report and then handing out the report statically. So they weren't optimized for query latency, and they definitely were not optimized for high concurrency, where you have, tens, hundreds, thousands of users using it. They were designed for the days where a small number of analysts would run the queries, build the reports, and hand them out. But in today's world, where you want to empower all of your employees and sometimes your customers and your partners with information, we're living in a world where you want hundreds or thousands or even tens of thousands of people trying to use that data through a dashboard. And the data warehouses suffer when you try to do that, as you talked about in the examples. Okay, so how do we fix it? Let's go to the first pattern. So the first pattern is what you see when people are mostly concerned with the query latency and concurrency, where I've got thousands of people or hundreds of people even trying to simultaneously hit this dashboard, and I'm overwhelming my data warehouse because the locking semantics and the underlying architecture that it has just isn't ready to support that. And even if I could support it, usually it costs quite a bit in terms of expanded hardware to meet the need. And so what you want to do is offload that to single store in this case. So you pull the data that you need for the dashboard out into single store, and then have the dashboards working off the single store instance to power the dashboard, giving you that concurrency and query latency that you need to make allow the customer to have a good experience. But you can continue to do your regular reporting and other workloads, maybe data science stuff off your data warehouse. So really having single store be an augment or an addition for the dashboard workload, but keeping other workloads on the data warehouse. So let's go to pattern 2. So like I said, that's good for query latency and concurrency. Now pattern 2 is where the requirement is more around streaming ingest, where you need to drive the time to insight, right? From the time a piece of data is born to the time that it has to show up in the dashboard. If you had an SLA around that time, that it'd be close to 0 or near 0, that's when you want to use what we call the Lambda architecture. That's a term that came up maybe, 5 years ago or so. And the idea is that you're forking the data from the original source and having the sort of fast version of the data go in one path, and then the slower data go through the batch layer path. So right, you still have the bottom path is still the same, where you bring the data in batches, you do processing and transformation, drop in your data warehouse, and then you can do your traditional reporting. But then you take the raw data, and generally you're not doing as much transformation aggregation because you're optimizing for speed. So you're dropping the raw data usually into some sort of event queue like Kafka, and then pulling it off Kafka, again in raw form into single store, maybe doing some light transformation, but most likely dropping it raw, and then doing aggregations on the fly as part of the queries to power the dashboards, allowing you to get to that data as quickly as possible in order to meet your requirements and power your apps. And that way you get the data sort of going both ways. Now, these two patterns are not mutually exclusive. There's nothing stopping you from really doing a combination of both. And we see this with a fair amount of our customers, where they want the real-time and the fast path, so they do the Lambda architecture, but they also want to supplement it with some of the data that they're processing through the batch process, because of the transformation aggregations are important to curating the data and cleansing it and getting it to certain quality. And there are cases where the aggregations, it doesn't matter if you have the nearest one, as long as you can join it with the most recent data. So when you want to combine the older curated data with the newer, rawer data, then the combination of the Lambda Plus architecture here works quite well for them. That's kind of the three patterns that we see in terms of how people make use of us. So now let's dive into some of the actual use cases and walk through how people use these patterns to achieve their end goals and meet their requirements.
Yeah. As we are walking through the use cases, I just want to remind the audience, if you have questions, feel free to put that in the chat window, and we can try and cover that after the session today. Go for it, Rick.
Okay, so let's go to the first case study. So this is a leading mobile phone and electronics manufacturer. I'll leave it to your imagination to imagine who this might be. And they were suffering from fairly slow and lagging dashboards that they were using to monitor their supply chain and their sales. They want to know, how many devices did I sell yesterday, in what regions, at what price points, what colors, all the different dimensions you might imagine. And by slow, I mean they were taking literally tens of hours to be able to process the data. So they weren't able to get the data in the day that those things were happening. They were having to wait till the next day to find out what was going on in their business. This impacted their ability across a bunch of different dimensions around how they're going to do product launches, how they did their marketing, how they did their manufacturing, how they managed their supply chain for knowing how much stuff to order. It was just causing a lot of pain at the exec level across the board. And they were seeing, not only were they having problems now, but as the data continued to grow and the number of users who are using the system continued to grow, they were going to see it was only going to get worse. Now, they tried doing this out of Teradata, and Teradata is a great system, was able to handle the complex queries, but it wasn't able to handle the kind of concurrency they were seeing. As more and more of their users on the system, the exec level, and then additionally more of their users, like in the sales and marketing departments, are trying to use it, and getting to hundreds of queries per second, the system was bogging down and not able to perform. Now, they tried putting a MySQL in front of it as a data mart to try to build the data mart pattern, but MySQL couldn't scale out and handle the growth in data of 4 billion rows per day. And so the whole system just bogged down and basically became unusable. So they put in single store, and the results are they were able to get to a rate of 12 million rows per second ingesting into single store. So it met that real-time requirement without having to have any delay. So going from hours of delay to basically real-time. And then they're able to hook Tableau up on top of it. And that's possible because we're MySQL wire protocol compatible, which basically means you can use any tool that works with MySQL, which is pretty much every tool out there, just naturally works against single store as well. So they hooked up Tableau and are able to get these real-time dashboards and use that to affect their business. So in terms of results, they're able to ingest their 4 billion of rows per day without any trouble and basically in real time, and still deliver consistent query performance of less than 100 milliseconds for all the queries, even in the face of concurrency of 160,000 queries per second. Pretty impressive results.
Oops. Sorry about that.
All right, don't want to miss out on number 2. This is an exciting one. So this is a leading cybersecurity company, right? And cybersecurity, real time is really real time, right? Not every second counts, every millisecond counts, because you don't want to ever have a threat go by that you're not able to see and react to, because every moment could lead to more loss or more breaches in your security. And this company was struggling with their existing architecture because it was taking minutes for them to identify new threats, which is an eternity in that world. And so their customer experience was suffering because the pages weren't loading and the customers couldn't see what was going on in the system. And that was really eroding their competitive advantage and making it difficult for them to compete. In this case, they were using Snowflake, and their queries are slow, and especially slow during high concurrency times, meaning when everybody's coming in and when there's something going on in the system, and that's usually when it's most important to be able to have a good experience for the customer. That's when they are hitting their slowest moments. On top of that, at the time, Snowflake didn't have native ingestion from Kafka either. And so it just led to a pretty poor experience for their customers as they started to hit concurrency loads of 1,000 queries per second, and failing to hit their SLA of keeping the queries under a half second. So they moved to single store, and they're able to then ingest millions of records per second, achieving their goals for bringing the data in real time, and able to deliver much better results. Basically, 180x improvement in the speed to report a new data. Pretty eye-popping results there. 180x, a 15x reduction in data ingestion latency, and managing to deliver all of their queries in half a second, even at 1,000+ concurrent users on the system. So pretty amazing results. The customer was extremely happy with their ability to deliver that and deliver an amazing customer experience for their users. So that leads us to number 3, which is a media company in North America that had built an application to do sales of their ads. So as they had some important media event, they had hundreds of sales folks that were out selling these ads to the advertisers. Now the problem they had is that the advertising sales application that the salespeople had was slow to be able to process the transactions. Once an ad was sold, then the data had to be fed back in so that it could show up as marked as sold in the inventory, so that somebody didn't go and accidentally sell it again. And it was taking 2 hours to ingest the new transactional data back into Redshift after it was been processed, which meant there for a 2-hour window, that ad space, that time slot would show up as open when in fact it had already been sold. And this led to sales execs double selling and then having to go back to a customer and say, sorry, that thing we sold you that we told you could have, turns out we don't actually have that, and then trying to have to work through that experience with the customer. And with ads contributing to 32% of their revenues, a third of their revenues, that's a pretty painful experience to have to do with your customer, and it results in grumpy customers and people pulling back on their willingness to buy you in the future. So a 2-hour delay and then a 5-minute latency requirement on queries is just too slow and unacceptable for the customer. And when they moved to single store, they're able to replace or augment Redshift in this case. They were still using Redshift for other parts of the application, but for this customer or the user-facing portion of it, they switched to single store. And here they're able to ingest all of their records within seconds, basically making it a real-time update of the system so that inventory never got double booked, and maintaining pretty high levels of concurrency. Even when they're having big events and all the users are coming in at once, they could scale to as many users using the system without any performance degradation and providing a snappy interactive experience, and really reduce their double book sales basically down to 0, which improves experience overall for everyone. And the fourth, last but not least example is this. It's actually a fintech startup who's disrupting the fintech industry. And basically, they're using a mobile app to deliver financial transactions. And they were trying to use BigQuery in the back end, but the queries were so slow and the loading was so slow that the app took so much time that people basically were unable to use the app. They're trying to handle the writes from the app with, and they got to be, once they got to 100 of concurrent users, they couldn't get the transactions to go in fast enough, and they couldn't get the queries to load. And so what resulted is that people would load up the app and the screen would just sit blank for tens of seconds or even minutes, resulting in a pretty poor experience. And customers are pretty unhappy, and it just made that app basically unusable. So if you go to the next screen, you can sort of see the before and after who's built it out. The ratings and reviews that people had were like, they're getting 1 star saying, download the app to check it out, and nothing is loading. The app was blank. I couldn't refresh it. And once they moved to single store, they started getting amazing reviews because everything was snappy and interactive, and they were delivering the results that people expected. So that's our four use cases, and I'll turn it over back to you, Vijay.
Yeah, thank you, Rick. Yeah, I think the beauty of this is, again, it ultimately all goes back to the end user experience or the end customer experience. I would say the common theme, as you saw across in all of these case studies, again, the first 3 were, it was dashboards. Some of them are internal dashboards, some of them are external customer dashboards. But the 4th one, this is an application, right? This is an app. This is a mobile app that they're trying to power with the traditional data warehouse. It just wouldn't scale to the concurrency and to the performance levels that they need. And then they want to really, amp up the customer experience, and that's where they bring in single store to kind of augment their existing infrastructure to drive that, drive that oomph, if you will, to really enable some of these use cases. So the common thread, as I was saying earlier, was, if you're running into these challenges around, dashboards not loading or applications not performing or performing to the level and the customer experience suffering, or the data being stale, those are all symptoms that, hey, you know what, there is some bottleneck somewhere in that workflow that we talked about, and we, augmentation might be the right solution for some of the things that you're looking at, right? Now, across all of the use cases, you saw a certain set of themes, right? Number one challenge that all of the customers had was, how do I get this data into the data warehouse? I mean, getting the data, loading the data was kind of the primary challenge, right? And that's what single source, right, is solving with real-time data ingest, where you can do parallel ingestion at high scale from different sources, diverse set of sources, batch, streaming sources with Kafka, from Spark. You can directly load data into single store. So that's number one. The second consistent theme that we saw was that performance, query performance, right? So for example, some of the previous examples you saw, Rick shared, 5 minutes to return a query, right? 10 minutes for the dashboards to load, right? So it was just not able to scale to the volumes and to the concurrency needs that the customer was looking for. So again, if you're looking for fast queries, second latency, sub-second latency, again, another great opportunity to kind of augment your data warehouse with the data engine such as single store to power some of these use cases. And last but not the least, again, very consistent theme across all of the 4 examples that you saw. Some of the, data warehouses and some of the traditional data engines would work when your concurrency and loads are low, and if you're, if there are not much concurrent users or queries hitting your application dashboards, it might work fine. But the moment, as you saw in some of the examples with the mobile phone manufacturer and others, as their data volumes start to grow, as the number of users start to grow, as the concurrency needs start to grow, it surely hits a bottleneck within that existing workflow. That's when you need to kind of start to kind of think about, hey, how do I augment my performance? How do I augment my data warehouse to really drive performance to my end users, right? And these are the 3 key pillars, as we talked about earlier, that single store brings to perspective. Real-time streaming ingest, super fast sub-second latency queries, and then, high performance with high concurrency needs, right? That's what single store solves for our customers today. And what this enables is, this has enabled us to support a variety of use cases across a range of industries, as you see here, right? Everything from financial services to telecom, to up and coming technology disruptor kind of organizations, all the way to energy and utilities. So we are powering everything from real-time fraud analytics to portfolio management and wealth management for tier 1 financial services institutions, to to some of the fintech disruptors that we talked about, who are trying to solve trying to do algorithmic trading, crypto exchanges, so on and so forth. Into telecom, we're talking about things like 5G analytics, network telemetry, geolocation analytics, right? Great use cases that we're solving today for some of the leading telco and communication service provider in that market. If you look at media and streaming, things like streaming media quality analytics. So customers like Hulu, they're trying to do, hey, how do I optimize my streaming quality in real time as I'm streaming content out to my subscribers, right? And all the way out to the far right, to energy utilities, where they're trying to solve things like IoT and smart meter analytics, predictive maintenance, so on and so forth. So very, very interesting use cases that we are able to enable for our customers across all of these diverse verticals. Okay. So hope that was really helpful. That gave you a sense of how customers are why customers are augmenting their data warehouses today, and then how single store is able to help them augment the data warehouse to run, basically to turbocharge their applications, to turbocharge their customer experience, to turbocharge their dashboards and IoT analytics, so on and so forth. Okay. With that, we'll open it up to Q&A. I see some questions have already come up, so let me open up the questions real quick. So Rick, this first question is for you. Interesting. So back to the patterns, Rick, that you were covering. Is single store not a replacement for a traditional data warehouse as well, given the column store functionality within single store? Rick, if you're talking again, you're probably on mute.
Thank you. Yes, you can use single store as a traditional data warehouse, as well as for the patterns that we described. So that is something that people can do, but often they have investment or they have needs for their existing data warehouse, and we're just showing the pattern of how you can use single store in addition to an existing data warehouse. But you could use single store as its own data warehouse as well.
Fantastic. So another question that that has come in is really around, does single store offer separation of storage and compute like some of the other data warehouse providers?
So today the compute and the storage are typically bound together into a fixed ratio. You can set that ratio to whatever you want, so it's not totally fixed, but once you fix it for the cluster, then changing it's not quite as easy. But we are building a separation of storage and compute. We call it bottomless as our code name. And that's coming later this summer. And it'll work very similar to the way that other separation of storage and compute type databases and data warehouses work, where you put data in and it gets put into blob storage. The amount of storage can be basically varied separate or separate. The ratio is basically independent of the amount of compute that you use. And so if you use more storage than you can store on the cluster, then it just evicts it. Essentially, it keeps it cached on the cluster, and then as you need data, it automatically brings it in. So there'll be more on that as we roll it out later this summer, but it's something we're working on.
Great, fantastic. So there's another question that just came in. I assume you're making a copy of the data warehouse or a portion of the data warehouse when you move the data into single store. Do you then run into issues keeping the two separate data stores in sync? Is that a challenge that you run into?
Generally with data warehouses, the data is not being changed in single store. It's a read-only copy. And so it's a one-way synchronization, which is relatively easier than doing two-way synchronization. So it's generally not too hard to keep it in sync. And we certainly don't have any trouble keeping up with the amount of data coming in. We can usually, for certain, we can handle the loading into single store faster than you can load into your data warehouse. So you don't really have any problems on speed and keeping them in sync. It's just a matter of updating the data as it comes in. Like I said, because it's generally a one-way sync, it's pretty straightforward.
Great. And I see one more question coming in. What technologies or how are customers really moving the data between data warehouse and single store? What are some of the ingestion patterns that you use?
Yeah, we see a couple of different patterns. In some cases, people are using ETL tools that know how to pull out of one system and put into the other. And pretty much, like I said, we're wire protocol compatible with MySQL, so pretty much in any of the ETL and CDC tools that are out there will work with single store. On top of that, other people will then often take the data out and do an extraction. Most of the data warehouses have an extraction mechanism, and then they can dump it into something like S3 or into Kafka. And we have native mechanisms that will easily pull from S3 and Kafka. It's a feature we call pipelines, which we've done a lot of other talks on. But basically with a single SQL statement, it will continually pull from those locations. So if you can easily get your data into S3 or Kafka, then getting into single store is trivial.
Great, fantastic. I think those are all the questions we have for now. But again, if you have questions, feel free to reach us at managed@singlestore.com that you can see here. But more importantly, you can get started for free with single store today. You can get $250 in free credits today. Just go to singlestore.com/managed service, or just go to singlestore.com. On the homepage, you have a free trial that you can get started with and really get your hands on the product. Okay. With that, I want to thank Rick and the team here, and also I want to thank each of you for joining us today. Hope you really enjoyed it. You will be getting a recording of this the presentation and the talk that will be sent to you in the next couple of days. So you should have this soon. So with that, thank you once again. Have a great rest of the day. and see you once again soon. Bye.
Great. Thank you.